All right, welcome to our final presentation for Chem 117. Our research is space debris in oceans. Our group members are Anjali, Caleb, Tejas, that's me, and Barbara. So what exactly is our project about? So we researched on how space debris contributes heavily to pollution in the oceans. So we looked at a few pollutants, and the main ones that we found were heavy metals, plastic, and paint. So space debris, like I said, includes corroded metals. So that includes chromium, aluminum, nickel, and iron, and so on and so forth. And they disrupt the balance of the ecosystem. Then there's plastics. The decomposition of these tiny plastics into tiny microplastics injures sea creatures that unknowingly consume them, and this causes neurological problems, physical problems, and chemical toxification. And finally, there's a lot of debris that does not corrode or break down, so it just sinks into the deep sea, and it impacts the flow of water and causes habitat problems for deep sea fish, anglerfish, and the list goes on. So what does chemistry have to do with it? Well, corrosion is part of chemistry, of course, and there's a lot of imbalance in the water when these reactions occur. So these reactions, so the metal reacts with the water. Usually, there's a bimetallic corrosion, which is basically two metals take part in the reaction because the metals like a metal is plated on top of another metal. Then there's leakages. So chemicals in some of the parts can leak into the water, and it dilutes the water with a few acids or alcohols or any sort of combustible material.
So the duties and agreements between our group members. So to make our process of working as a group efficient, we decided to allocate four different roles to each member. So for Barbara, we put her in charge of the whole team. She was our team manager. She was in charge of the final submission, overseeing the team members and making sure everything is delivered on time. Tejas was our team facilitator, and he was responsible for organizing when our group would be meeting and working together. Uh, for me and Jolie, I was a product manager, and I was in charge of organizing and overseeing the development of this video presentation. And lastly, we have Caleb, who was a research facilitator, and he was responsible for ensuring the quality and efficiency of our work being done by each team member. What challenged us as a group? So one of our main issues that we had working together as a group was that we each have very different schedules. So it was a bit difficult finding times where we could all come together and work on our assignments. However, we did overcome that by maintaining good communication with each other and compromising when we needed to. Our initial individual proposals. So initially we had 5 different proposals. Our first one is the one that we did use, which was space junk and its pollution into the ocean. Our next one was how noise from aircraft and rockets can disturb the sea. VHF radio limitations, vessel materials, and power generation failure on boats.
So, like Angeli said, the problem that we chose to talk about in research was space debris and how it pollutes the ocean. And the reason why we chose this problem was because it's the one that we felt could relate more to chemistry, at least more directly. And it's a prevalent issue that's come up in recent years since technology to explore space keeps developing more and more as the time goes on. And it's again, it's since it's a current issue, there's not much to be done or research yet to resolve this issue.
So these are the findings that are related to our proposal. First is the Selma shipwreck, and then we have the sulfur pile and battleship Texas. And then here are the GPS locations, on the ocean, and so they all experience some degree of corrosion.
So, for the Selma shipwreck and how it related to our issue and our proposal is that this shipwreck has been corroding for a couple of years already, and it's still undergoing the process of corrosion. And we found that the corrosion of this ship is very similar to how like space debris corrodes in the ocean and like similar materials in general. And both of these can pollute the ocean by releasing toxic substances and chemicals that can damage the pH of the ocean, marine life, coral reefs, and other stuff like that.
Next up is the sulfur pile. Sulfur is used a lot to aid in ocean pollution. It does this primarily in two ways. First, it does this by helping maintain the pH balance in the affected area. So where chemicals leak into the area, sulfur can be poured in, which helps maintain the pH balance and reduce the effect. Next is it helps with oil spills. So where there have been oil spills by ships, tankers, um, it can be poured into the ocean and it causes the oil to clump together and sink to the ground to reduce the affected area. Sulfur is also used in various space exploration projects for chemical synthesis and in production of fuels. Next up is Battleship Texas. It's a key example of how corrosion affects sea vessels. Um, it served in the U.S. Navy for quite a while, and so received corrosion effects to its hull and frame, and it was repaired quickly after that.
So, what methods can be used to solve this issue? Again, since this is a recent issue that has started to come up more and more with the years and the developments of space technology, there's only a couple of methods so far. And the first one is satellite tracking systems. So the use of these is to predict a precise location in which the debris might fall off when it enters the Earth's atmosphere, because a prevalent issue is that sometimes there can be a range of where the debris is gonna fall, but we won't know exactly where in the ocean it's gonna fall, and like that causes issue when it comes to retrieving the space junk. And then the second method is that we can use catching mechanisms planted at a already decided location, or at least a range of where the debris is going to come into, so that as soon as it enters the ocean or it's near the surface of the ocean, these catching mechanisms will go off to catch it, and so that it won't cause harm to ocean life. And then the third one is the use of reusable rockets. So this will minimize waste in general and not just make it healthier for the ocean. And it will make our research and exploring of the space a bit more sustainable.
Scientific evidence from the literature. So our sources that we included in the presentation gave us information as to what exactly space junk is, what are ways we can solve the issue, and also how it affects the ocean. So to answer the question, what fields of science can help to alleviate this issue? So aerospace engineers are vital participants in designing satellites, and they can design satellites that can keep track of microplastic concentrations throughout the world's oceans. And this issue of space junk into the ocean does negatively affect the marine environment because when marine life ingests the microplastics, it damages their digestive systems over time. And this picture right here in the middle is a graph of the concentrations of microplastics tracked by the satellites I previously mentioned.
Okay, so and then finally, these are resources that we used to research our topics and our methods of solution. And then we mainly used NASA as our source. And that's it. Thank you for watching our project.